Hey guys, Taste here from the Code with Taste channel. Finally dragged myself away from that Christmas turkey and read a book. The book was called Diary of a CEO, and in that book an interesting point was raised that got me thinking. Asking is better than telling, when it comes to influencing someone's behavior, of course. But in this video, I'm going to be asking the opposite question. In object-oriented code, should we stop asking and start telling? So we write our code that tells objects to do things, and this promotes designing your classes in a way that tries to focus on behavior, whilst using encapsulation to hide its internal workings. So a common scenario we have in our code could be this, and we have all been guilty of it from time to time. We have a simple account class, so let's stick that in here. So we have something like this, a simple account class, okay? And we are going to simulate a repository class that returns the account details from a database, okay? So usually we have something like this, okay? So you've got your account class there, and it's got the ID and balance, and then you have your repository that you usually use, provide some sort of ID, and it will go to a database and it will return a list of accounts which you can then filter with this. But we're going to simulate that to just say that it returns this a hard-coded account, okay? And finally we have a service, some sort of service. So in this case it will be an account management service that has all the business logic within it. So let's stick that account management service in. Cool. So as you can see there, it's got a minimum amount and it's got a method to get balance, okay, which when you provide it with an account ID, it will call that repository that we created and hard-coded basically, and return that one account version that we have, okay? And it will then use that account to print the, let's get rid of that account balance. Yeah, we'll use that one account to print a balance to the console, okay? And that's if we call the get balance method. If we want to make a payment, then that method requires an account ID and an amount, and again it calls the repository to get the account, okay? And then we ask the account balance, the balance, and then obviously we compare that with the minimum amount. If the account doesn't have enough money to make a payment, then there's not enough, it prints to the console that there's not enough money to make this payment. Otherwise, it makes the payment by minusing the amount from the payment amount provided from the account balance. Cool. So essentially we have a function that gets the account balance and a function that makes a payment. Now, what's wrong with this code? And I'm putting the word wrong in quotes here, because it's obviously dependent on your point of view. But in some people would say nothing. It looks reasonably fine to me, okay, or would look reasonably fine to some people. But the account management service, however, seems to be doing a lot of asking. Okay, so it asks the account object for the balance. Okay, so where is that? So here it's asking the account object for the balance, okay? It also updates the account's balance, okay? Which begs the question, is this what we want in our application? So, well, what if we want to modify this code to add more functionality, okay? So what if we wanted to add a savings element to this functionality, where an account can transfer money from the balance, so it can transfer money from the balance into a savings. So we can extend that by adding a savings property. So let's do that, okay? And then in the account management service, we can add a new method, I guess, that would deal with transfer. So let's stick that in and see how that works. Bear with me 1 second. So cool. So this is going to handle transfers. So again, same as before. We provide a account ID and the amount we want to transfer. Okay, and obviously we've got to access the repository layer to get that account, ask for the balance, and then if there's not enough, if there's not enough, we've printed a screen that there's not enough money to make the transfer, and if there is enough, then we add it to the savings, which is there. Okay, so you can see both classes are growing in the account information, or in their account information, obviously. So with more account logic being added to the account management service. Okay, so obviously we've got more accounts in specific logic being added to the service. Its focus should just be to provide a balance and make payment and transfer. So ideally, the whole purpose of this account management service is to be focused on providing a balance, making a payment, and obviously making a transfer. But now it's actually saying, okay, well, get me the account, okay, and then I'll print the balance, which is correct, I guess. But in the make payment version, it's getting the account and then obviously doing some logic checks first, some account logic to see if we have enough money to make the payment, and then making the payment rather than just making the payment. Okay, and then it's the same thing with the transfer. It's doing some validation logic to check if there's enough money before doing the transfer, rather than just doing one thing, which is just doing the transfer. Okay, so let's make this code so far more object oriented. Okay, and how we can do that is with the tell version. Okay, so let's add the code for that. Let's get rid of all this. Okay, and let's put in the tell version of the account class. Okay, that's grown significantly. And then the tell version of the account management service. Okay. We don't have the let's obviously stick back in the account repository, because that's going to stay the same. That won't change. So let's stick that in and let's go through what we've got. Cool. Ooh. What have we got? Why have we got an error there? Okay, what's the error here? There is no argument given that responds to the required ID. Okay. Ah, yes, of course, yes. So let's clean that up and have it as ID and one M. Okay, because it's being created now with the constructor, and that should work fine. Cool. Okay, so let's go through this first of all. Okay, so now we'll start off with the account class. As you can see, we have a private we've moved the minimum amount logic into the account class now. Okay, now we've implemented this private set and private balance, and a private set for the balance and the savings and the ID, so meaning that they can only be set within the account class, but obviously you can access that with the get if need be. Okay, then we now use a constructor to initialize the class with the ID and the balance. Okay, and then obviously we've moved the logic for transfers and the payment within the account class. Okay, cool. Then we also have the account management service, and all this does now is it still does its original it still utilizes the original functionality of getting the account balance, making a payment, and transferring to savings. However, as you can see, it's a little bit more lightweight now, as it only makes a few calls, one to the account repository to get the account ID, and then it obviously prints the balance, which is the same as before, so we didn't change that. But when it comes to making a payment, rather than asking for the account balance and things like that before making the payment, it just tells the account class to make that payment, and then it's up to the account class to decide if it wants to make that payment or not, and it does its validation and obviously makes that payment. Okay, the same thing with the transferred savings. Okay, again, the account management service is telling the account class to transfer the money, and it doesn't really care about whether, you know, the logic, the validation logic. It just tells the account class to obviously transfer the money, and it's the account class that then decides, you know, should it transfer the money or not. Okay, and then displays the relevant notification to the user if it doesn't want to do that. Okay, and then obviously the repository class has now changed slightly, obviously now to create the class, because it's a private set. We can't just access these fields directly and change them. We have to use the constructor to do that, and obviously follow the rules of the constructor in order to access these fields, you know. And yeah, so it's changed significantly from well, not significantly, but obviously you can see the changes there. Cool. So what are the so basically what benefits do we get out of this? Okay, so well, for starters, the account management service obviously looks more focused now. It's it only worries about its responsibility, so the responsibilities of getting the account balance, making the payment, and transferring to savers. So it doesn't really care whether the account has enough money. Okay, so that is the responsibility of the account class. It just tells the account object to make the payment and transfer to savings, as I said earlier. Okay, and once it's told the account class to do that, to either make the payment or transfer, it's done with it. It doesn't care about anything else. Okay, all the logic has been encapsulated into the account class. Okay, and the majority of the account class's members are obviously protected. So, you know, we only expose what we want you to know, and obviously it's protected, so you can't set these values outside of the class. So as you saw earlier, when we tried to manually set it here, when we did try to set it using the account, create a new account like this, equals ID, it wouldn't let us do that because it's you know, a private set. Okay, so we can't access that. Okay, so you know, there is a strong, so basically, essentially, in a nutshell, there's a strong focus on abstraction, and all the information you need is essentially located in one place, which is this account class now. Okay, and it thus eliminates or limits code duplication, because, you know, I could have multiple account account services that could essentially do the validation to make a payment in different ways, and rather than doing that, it's all done in one place. So all the services that we create that utilize this account class, if they want to make a transfer in different ways, all they do is just when they're ready, they just call the account service and make the transfer, and essentially it does the same validation in one place. Okay, so what are your thoughts on this principle, the ask and not tell principle? Oh, sorry, tell and not ask principle. I would love to hear your opinions on this, particularly in the code first approach, which is what most people use when designing their web APIs, you know, where you have obviously, you know, your data entity model with, you know, the normally you'll have like a decorator for key above that, you know, above this, your ID and such and such. How do we feel about implementing this kind of logic within here? Cool. Please leave all your opinions in the comments. And that brings us back to the end of this video. Please look out for more videos on the channel and have a great day.